Hello, 8th graders. We are going to talk about compound inequalities this evening. So this is Chapter 6, Section 3 on the notes that you should be taking. So a compound inequality consists of two inequalities and is connected by the words and or the word or. So, for example, if we were to write this example, all real numbers that are greater than or equal to -2 and less than 3. So I start off by doing two different inequalities. I start off with x is greater than or equal to -2, and I also write x is less than 3. And when you have an and statement, you combine it into one sentence, I guess you would say, or one type of inequality. So here you can see x is less than 3. You keep that there. And then if I were to write this and flip it around, then if I have my -2 on this side, on the left side, my x on the right side, then I also change my sign. And that's what this says. -2 is less than or equal to x, and then x is also less than 3. And then I would graph these, and I'm essentially graphing up top. Okay, so if I have x is greater than or equal to -2, I have a solid dot, and I know it goes to the right. And then I also graph x is less than 3 on the same number line. So I have an open circle on 3, and I go to the left. And you can see here, they actually will overlap. And that's what you're looking for. When you have an and statement, you will see that these 2 points will be connected. And so this is pretty much what you're looking at. So x can only be between greater than -2 and less than 3. And that's exactly what it says up here. So let's do an or statement. So here's our example of all real numbers that are less than or equal to -3 or greater than 0. So in our or statements, we have to keep it as 2. So I write x is less than or equal to -3 or x is greater than 0. And when you have these, you will graph these. So I have a solid dot at -3, and my arrow goes to the left. And then I also have an open dot or circle at 0, and my arrow goes to the right. And so when you have or statements, they do not overlap. There's some type of space, or the circles are next to each other, but they do not connect, and you have essentially a space in the middle. So it can either be less than -3, less than or equal to -3, or greater than 0. So it can definitely not be -2 and -1. And that's what that or statement does. So here is an example of like a real life situation. And how will we write this? So it says write an inequality that describes each condition. So water is a non-liquid when the temperature is 32 degrees Fahrenheit or below, or is at least 212 degrees Fahrenheit. So this is an or statement. So I have T as in temperature has got to be less than or equal to 32, or the temperature has to be greater than 212. So that's just an example of how you would write it. Here's an and statement. A fridge is designed to work on an electric line carrying from 115 volts to 120 volts. So that's the only way it's going to work, is if it's in between these two. So it has to be greater than or equal to 150 volts, and it has to be less than or equal to 120. And again, when we write our and statements, it's best to write it as 1. And you usually have your list number down here, so if I were to graph it, would make sense. So essentially this says the same thing. 115 is greater than or equal to V, and V is less than or equal to 120. So again, there's my thing. You write compound inequalities involving and as one inequalities. You write compound inequalities involving or as two inequalities attached with the word or. So that's just a reminder of how I would like it set up for formatting. So let's do ones that have multi-steps to them. So this one says solve by isolating the variable x between the two inequality symbols. So you can see here it says -5 is greater than or equal to 2x plus 3, which is less than 7. So you can see here I have two inequality symbols. And so what we have to do is we have to treat this as two separate equations. So we have -5 is less than or equal to 2x plus 3. And then my other equation is 2x plus 3 is less than 7. But I can do this all in one. So first I have to get x, and I have to isolate x. So what you do is first I gotta get rid of my 3. So I subtract 3 from this side. What I do this side, I actually do to all my sides in a sense. So here, because I look at it as this is 1, and then here's another one. So 2x plus 3, I subtract 3, and I subtract 3 from each expression, so from each side of each inequality symbol. So I subtract 3 here, subtract 3 here. I get negative 8 is less than or equal to 2x, which is less than 4. And again, I isolate x. So I divide by 2. What I do to both of my inequalities. So I do it over here, 4 divided by 2 and negative 8 divided by 2. And then my final answer is negative 4 is less than or equal to x, which is less than 2. And then I will graph my answer. So if I look at this equation, negative 4 is less than or equal to x. If I flip-flop it around, it's the same thing as saying x is greater than or equal to negative 4. So I put negative 4 solid dot, and it goes to the right. And then I have x is less than 2. So that's an open dot, and then it goes to the left. And you can see, since it's an and statement, because there's only one variable in there, they should overlap and connect from one dot to another. Let's do an or statement. So or statements you basically just keep as individual equations. So I have 6x minus 5 is less than 7, or 8x plus 1 is greater than 25. So you just do them one at a time. So we'll start on the left. And again, you isolate your variables. So you add 5 to both sides. 6x is less than 12. Divide by 6, so I get x is less than 2. On my right side, I have 8x plus 1 is greater than 25. Subtract 1 from both sides. 8x is greater than 24. Divide by 8, so x is greater than 3. And then I will graph them. Now this is an or statement, so if our graph is correct, you will see that they do not overlap. So I graph x is less than 2, open circle at 2, going to the left. X is greater than 3, open circle at 3, going to the right. And you can see right here, there's that space of where they don't overlap. And then one last thing to go on is when we are reversing our symbols and our inequality symbols, but we reverse it with both sides. So like an and statement. So I have solved negative 3 is less than negative 1 minus 2x, which is less than or equal to 5. So I, again, treat it as two types of inequalities, but I'm going to do the process all in one step. So I isolate my x. So I need to get rid of my negative 1. I add 1. What I do to this, I do to both of my other two. So I get negative 2 is less than negative 2x, which is less than or equal to 6. Again, isolate. Well, when I divide by a negative, I always flip my sign. So when I divide by a negative, I divide by a negative on both sides, and then that means I need to flip both inequality symbols. So negative 2 divided by negative 2 is 1. Flip my sign is greater than x. Flip my sign is greater than or equal to negative 3. And then I rewrote it so that it made more sense to me when I graph it. And I have negative 3 is greater than or equal to x, which is less than 1. And when I graph it, since it is an and, it should be, so if I think of it, negative, so I said x is greater than or equal to negative 3, solid dot, going to the right, and x is less than 1, open dot, going to the left, and they connect, so there is my graph. We will do some problems in class with you, but enjoy the rest of your evening.